Hello, this is Mr. Rasmussen with Algebra 1 and Lesson 102. All right, we're going to be graphing some inequalities on a number line here, and all the ones in the lesson today introduced a new idea of doing it with absolute value. Now remember, what an absolute value does is it just states its distance from zero. So for example, if let me do a short little number line here in the corner. Here's 0, and if I put in this example here, let's put a 2 here and a negative 2 here. Well, how far away is this point from 0? Well, it's 2 spaces. How far away is this point? Well, it's 2 spaces, and since distances are always positive, they're both a distance of 2 away, even though this one is in a negative distance. You could think about it. Okay, so absolute value simply changes it to be a positive number. You could think about it that way as well. All right, so in this first example here, we're given the idea of absolute value of x is anything greater than 2. And we want to be able to put that. What qualifies in that? Well, let's just think through that for a moment. Let's put a 1 in there. Is 1 greater than 2? No, it's not. So that wouldn't qualify. Let's put in a 4. Is a 4 greater than 2? Yes. Is a 3 greater than 2? Yes. How about a 2? Well, 2 is not greater than 2. It doesn't have the equal sign, so that wouldn't apply. Let's switch to negatives. If I put 3 is greater than 2, if I put in a negative 3 in here for x, what's the absolute value going to do? Well, the absolute value is going to make it a positive, and is a positive 3 greater than 2? Yes, it is. So, as we graph this here, what we want to do is we're going to simply look at it, first just look at it in the positive, so x is greater than 2. Okay, so we would come over here on our number line, put an open circle, because it's not equal to, and then draw an arrow going to the right to show that it's anything greater. However, because we have this absolute value in here, then we also want to come over here to negative 2, okay, and use that, because any number put in here that is negative is going to become a positive because of the absolute value. We put an open circle and an arrow going this way, and there's our graph for example number 1. So it reflects itself onto the other side and does the same thing on that side is basically what happens. And I decided to do lots of examples, all the examples they give, to try to get a handle on this, because it is a little different than intuitive. However, it's a great exercise here in this lesson to think outside of the box and think a little differently than you're used to thinking. Okay, let's look at example 2 here. Absolute value of x is anything less than or equal to 3. So first of all, we can just think of it straight as, okay, here's 3, okay, and includes 3. So let's put a solid circle there. And x is anything less than. So the bar is going this way. How far does it go? Well, let's reflect that across. Negative 3 is going to become a positive 3, so it's really no difference. Let's put an open circle there. However, if we go this direction, negative 4. Negative 4 becomes a positive 4. Is positive 4 less than 3? No, it's not. So our bar is going to go this way, and we're going to have a solid bar between 3 and negative 3. You can see it just reflects across. Okay. Let's look at example 3 here. Once again, I see a negative 4 sitting in there. That's different, okay? Let's think through this. If I put a positive 1 in here, is a positive 1 less than negative 4? No. Let's put in a negative 1. If I put a negative 1 in here, the absolute value makes it a positive, therefore also doesn't work. Is there any positive number that's less than negative 4? The answer is no. So on example number 3 here, really, we could write this here as a null set. Nothing works for that. We can't have any absolute value of a number be less than 0. or I mean, I don't know if it can be 0. Anyway, so that one does not work. If we flip the sign, though, look at example number 4. If we flip the sign, since the x becomes a positive number, is there any positive number that is not greater than -4? No, all of the numbers here, every positive number is going to be greater than a negative number. So this one here is actually going to be a solid bar on every number. And you think about it, let's put in -5. -5, absolute value becomes 5, and is 5 greater than -4? Yes. Put in a 0, the absolute value of 0 is 0. 0 greater than -4? Yes. Okay. All right, let's look at example 5 here. And this starts to get a little tricky because we got this extra negative in there. What we want to do is clean it up first. Okay, so we want to get x in, the absolute value, by itself. So we're going to divide both sides by -1. That's going to get cancel the ones there. Get x by itself. Remember, when we divide by a -1, we have to flip that inequality sign. And then -3 divided by -1 becomes a +3. So we're going to clean it up, get the absolute value of x by itself, and that's going to change our equation to this, and then we're going to graph that. So +3, reflect that across to the -3 as well. It's got the equal sign there, so we got solid circles sitting in there. And then x is anything less than, so it's going to have a bar connecting right down the middle in between them. Okay, if it was a greater than sign, then it would be going out toward the edges. Okay, let's look at example number 6 here. Same thing. First, let's clean this up. X has got a negative there, and it's also got the -2. Let's deal with the -2 first. Let's add a 2 to both sides to get that away from the x. It's going to cancel there, and we're going to get a -3 here. Then we're going to divide both sides by -1 to cancel out this negative here. So we get absolute value of x. This sign has got a flip, and then we've got a -3 divided by a -1. Looks like we get this here. Which is very similar to our previous problem, with the exception that it doesn't have the equal sign. So we get a 3, reflect that across to -3, open circle, and x is anything less than, so a bar between them. Okay, hope that worked well for you, and so let's move on to our practice problems here. Go ahead and take the time to do these yourself, and then check your work with my work. All right, practice problem A, to jump into the hard stuff here, we got to reduce our inequality first. So let's add +9 to both sides. Gives me a -2 here. Cancels it there. Let's divide both sides by -1 to be able to cancel that negative away. That sign is going to flip. So I have the absolute value of x is less than -2 divided by -1. I can make that a +2. All right, so I got a +2. Right, +2, and then absolute value means I come over here and reflect it to the -2 as well. No equal sign, so it's going to be open circles on both of those, and then x is anything less than the 2, and so it looks like I'm going to have a bar that connects in between here. Put that above so you can see it. There we go, and there's the answer to practice problem A. All right, practice problem B. Tricky a little bit here. We're going to put our spot at 0. It's not equal to, so we're using an open circle. It does not include 0, but x is anything larger than 0. So I'm going to put an arrow going this way because anything larger than 0 qualifies. And then because it's going to change it to positive numbers, I can reflect that across the other side too. So any number negative there is also going to qualify. -1 becomes a +1, that's greater than 0. 0.01 is larger than 0. -0.01 is going to become 0.01. larger than 0. The only thing that doesn't qualify is dead on 0. There's the answer to practice problem B. That one may be a little tricky, but maybe you got it. Okay, hopefully this makes sense to you. If not, seek some more direction from me here through text or a phone call. And have a great day.